Okay, so last time we left off and we were talking about troubleshooting low voltage. Well, here in your book it says, this is very important, transformers are rated in volt amps. Volt amps. So if you get a 40 VA transformer, that was on my contractor's exam. I'm sure it'll be on your journeyman. It's commonly called VA. The rating can be used to determine whether the transformer is underrated or drawing too much current. For example, it's quite common to use a 40 VA for the low voltage power source. This tells the technician that 24 volts, the maximum amperage transformer expected to carry is 1.66 amps. So how do they get that? The VA rating can be used to determine the circuit's drawing too much current. Maximum amperage, okay? A 40 VA transformer with a secondary voltage can handle a maximum current of 1.67. Now, how do you figure that out? What's the maximum amps this can carry? Volts, right? Volt amps. So the way we look at this is, if you look at your book right there, it says 40 VA, and you divide that by 24 volts, and it equals 1.66 amps. So here's the math formula you would use to simply get how much voltage, how many amps it would be. Okay, 24 volts and equals 1.66 amps for a 40 VA transformer. Now, how can you know what it's drawing? Well, before we did the TIM wrap with your ammeter for the W, the heat last week, so in the controls, so we could set your heating anticipator. Well, let's look at this for a second. Your book says to go to use your clamp meter, and we're going to do the 10 wrap. So right here, we're going to take R in the other side of the circuit, wrap it 10 times, and see what it says. Okay, whatever it says. Now your book says in this example, let's say it was drawing 7 amps. Well, you divide it by 10, the number of times you wrapped it, and now you have 7/10 or 0.7 actual amps. Well, that'll work with the 1.66 amp transformer because it's only drawing 0.7 amps. So that's how you would see how you would work that. Okay. Now the next page says troubleshooting low voltage circuits. You would use a voltmeter, VOM, which is your continuity milliamps and volts. That's what you got when you came to the lab, and that's your meter you use in the lab all the time. You know all about that. So it says, remember this, when power is present at both points of a load, the component should function. If it doesn't, it's bad. You can also check continuity across it and check it. Okay, so we did that already. Now, your book right here gets into something called voltage feedback. But right before it does that, it gets into troubleshooting low voltage circuits. And that's what I want to talk to you about now. Troubleshooting low voltage circuits. So let's talk about that for a second. And then we'll come back to that in a minute. Here on the board, I drew some low voltage circuits. See that? Let's see if I can get that bigger. Okay, so it's right there. Now, let's talk about this for a second. Here we have power coming from our transformer to R, which we've been discussing. From R, it's going to Y. Do you see that? Is that a good enough picture right there? Let's get you a little close-up. Nothing wrong with a close-up. Oh no, I'm getting dizzy. What's going on? Calm down a little bit. Oh, that's so much better. So we have power going to R. R is also connected with a path to Y. Y, the thermostat's closed. Remember, whenever there's a power source and a path, it will flow. So that continues to the contactor coil. The other side of the load goes to the transformer. I'm on this side of the circuit. If I put my meter here, I would read what? What if I put my meter right here? I would read what? Anybody? That's right, I read 24 volts because I'm on both sides of the circuit. But if I put it between R and Y on a call for cool, I should read 0 volts also right here, because why? I'm on this side of the circuit. This is on this side and this is on this side, so guess what? If I put my meter here, I'd read what? Let's say I put my meter there and there, I'd read 24 volts. Here I'm reading 24 volts, because I take that wire and put it here, and this wire right here, I'm reading 24 volts. But if I'm on the same side of the circuit, right? It's like, let's say I had power here, okay, going to my light bulb. And I put my meter here and here and read 24 volts. Well, what if I put my meter here and here? 0. I'm not going to read anything. Well, that's, when you put it on R and Y, and you read 0 volts, and you know you got power coming from your transformer, that means that circuit's closed. But, what if, what if the circuit's open? Now, as you can see, I'm on this side of the circuit at Y. Here, I got power here. So now, between R and Y, I'm reading 24 volts. See the difference between the two? R and Y, when I'm reading 24 volts, means the circuit's open. Okay? Means the circuit's open. Any questions about that? No, I don't have no questions. Okay, I just wanted to check and make sure you understood that, okay? Let's see where we could go with that. Anywhere else? Well, I don't want to do broken wires outside yet. Go into the condensed coil. I will tell you this. This is a quick trick, a little something you can learn in the field if you ever run into some trouble. Let's say you got a broken wire. Okay? You got a broken wire. Right there. I'm going to break this wire. Now, I don't have a complete circuit no more, do I? So it's not going to run. One thing I can do is, remember, neutral is ground here, is I can take one side of my contactor and connect it to ground. Instead of neutral. Now my unit will run. That's only for an emergency case, in case you have a bad broken wire and you don't have time to fix it, and the people really need it running until you got time to properly prepare it. But you can take one side and go to ground and the unit will run. That's an old thing we used to do in the field, in case we had a broken wire. All right, so now let's get into the next part of the board. All right, let's see where I gotta be with this. Okay, so now, who's that? What? No, it's over there. Yep, the bathroom? Yeah, it's right over there. Now, let's look at this for a second. Troubleshooting switches and loads. Let's look back on the picture board now, okay? Let's take a look at that. And we're going to troubleshoot right here on page 379 using those principles. Now we're going to troubleshoot some motors. All right. We're going to follow those switches to the loads, and we're going to see how this could be tricky for you, or not tricky, but how you can be deceived by a few things in the field if you're not paying attention. So we're going to get some of that troubleshooting going right now so you don't have these issues you got to deal with in the field. All right. Our job is to try to make you look like a superstar when you get out there. All right. Like, oh, can I say that? Woo. Okay, so. It says in your book, let's look at this picture right here real quick. All right. This is in your book on page 379. Let's look at the way they're doing this. Notice when I'm on both sides of my potential voltage, I have 230 volts. 115 and 115 together gives me 230. Now over here, this is open. When the switch is open, I won't get any volts across it. All right? I won't get any volts across there. Here, I'm not, because it's going through here. I don't want to confuse you. But notice here, when it's power passing and I'm on both sides, I can get it. But this one, I'm not on both sides because notice we have a short right here. So this one is not on both sides. Now this one, notice with an open winding, I have 230 volts across there. Right? I have 230 volts across there. Going with the principles we already showed you a little while ago. All right, any questions about that? If you ohm it out with your ohm meter to check resistance, you should have 0 ohms. Why? Because notice how it's open. When it's open, you have 0 ohms. So I want you to check this out in your book. Go to page 379, okay? And I'm going to show you this real quick. So we can look at this together, just like we were looking on the board. Okay? Notice here with the switch open. See the switch open? I'm on this leg here, and the power is feeding through here. So I got 230 volts. Across a closed winding, I'm on this side of the circuit, I got 0 volts. One side of this leg, which is 115, the ground is showing me 115. Okay? Now, that's with that switch open. Let's close that switch. Now, I'm on both sides, so I'm getting 0 volts. I'm on this side here. Here I'm getting 230 volts, L2, L1. But notice L1's a closed path, just like we drew on that board a little while ago. So I'm getting 0 because I'm on that side. Here, 230. Here, 230. Okay? Now let's look at this bottom one right here. Ooh, almost made this video 3D for a second now. Here we got 230 right here. And on this side of the motor, we still reading 0 because we coming through. But notice we still on this side of L1. All right, power's passing through here to this side, and it's the same voltage on this side. So whether this one's open or this one's closed, I have 0 volts. It's only when I get on this side can I read the other voltage. All right, you getting that right there? Now your next page shows you this. And I like this picture right here. See that picture? All right, a voltage is coming through, and since we on this side of it, we reading 0. But notice here on L2, We're reading 230 volts with an open. It's open. All right. And in this one, if we took our meter out, this is what we had on the board. It's open. I should read 0 ohms across it. No resistance through that because it's a broken winding. There shouldn't be any resistance across it. Now in this one, the last one, I'll show you this when you're doing ohms. Notice we can check ohms if we don't disconnect the wires through something else. It'll backfeed. Here we reading resistance through this winding. That's 3 ohms. So that's where we get the phrase feedback circuit, okay? Voltage feedback is the same phenomenon. We can get voltage feeding back through another motor, all right? And we don't want to do that. It's the same thing as the ohms. Any questions about that? Now this diagram they don't have on the board either. I'll go over it with you real quick. They're just showing you in a refrigerator the set of in series switches going to the load. Here's the contactor coil. If the low pressure control or high compressor control opens, the contactor turns off. And that does what? L1 and L2 open. Well, that's L1 side of the contact and L2, and the compressor motor is taken out of circuit because those will look like this. And when those open, this is taken out of circuit. All right. And notice the main thing up here is the timer motor that tells it what? When to turn on. If this closed, this would open. If this is open, all of this shuts down. There is no more cooling cycle. Now this closes and it goes into automatic defrost. And when the defrost is done, this switches back and the cooling can begin again. And notice defrost is turned off. Well, that's how the circuits in a refrigerator work, okay? A lot of control troubleshooting in this chapter, I know. But that's the way it works, and that's the way we roll. All right, that's going to end the one for today. The next one will be a short one on, we'll wire up a thermostat and show you the difference between a line and a pictorial diagram.